For generations, Pluto was seen as the forgotten world of our solar system. Small. Frozen. Dark. A lonely object drifting billions of kilometers from the warmth of the Sun. When astronomers reclassified Pluto as a dwarf planet in 2006, many believed its story had come to an end. It became little more than a frozen relic on the outskirts of our cosmic neighborhood. But science has a habit of surprising us. The deeper we look into space, the more the universe refuses to fit our expectations. Today, Pluto is once again capturing the attention of astronomers around the world, not because of its size, but because of the extraordinary mysteries hidden beneath its icy surface. Thanks to new observations from the James Webb Space Telescope and years of research following NASA's historic New Horizons mission, Pluto has transformed from a forgotten dwarf planet into one of the most fascinating worlds in the solar system. Instead of finding a dead, frozen landscape, scientists are discovering evidence of geological activity, shifting ice, complex atmospheric chemistry, and perhaps even the ingredients needed for life. The farther we investigate Pluto, the stranger it becomes. At first glance, Pluto appears simple. Its surface is covered by frozen nitrogen, methane, and water ice. Temperatures regularly plunge below -220 degrees Celsius, making it one of the coldest places ever explored. Sunlight arriving at Pluto is hundreds of times weaker than the light reaching Earth. To human eyes, the Sun would appear as nothing more than an incredibly bright star. Everything about this distant world suggests silence. Yet beneath that frozen shell, scientists believe something unexpected may still be happening. One region has attracted particular attention. A giant, heart-shaped plain stretching across Pluto's surface. Known as Sputnik Planitia, this enormous basin is unlike anything else found on the dwarf planet. Rather than being ancient and heavily scarred by impacts, its surface appears surprisingly young. The icy plains show very few craters, suggesting they have been reshaped over millions of years. That means Pluto may still be geologically active today. Huge blocks of frozen nitrogen slowly drift across the surface like glaciers. Massive convection cells appear to move ice upward from below before it cools and sinks once again. It's a process that resembles the movement of lava inside Earth's mantle, but on Pluto, the material is frozen instead of molten. This discovery completely changed scientists' understanding of how icy worlds evolve. For decades, researchers assumed Pluto had become geologically inactive billions of years ago. Instead, they found evidence of a world that may still be changing. Even more intriguing is what could exist beneath those frozen layers. Many planetary scientists suspect Pluto may hide a vast underground ocean. This hidden reservoir would be buried beneath thick ice, completely invisible from space. The heat needed to keep that water liquid may come from radioactive elements slowly decaying inside Pluto's rocky core. Although the energy released is extremely small, billions of years of continuous heating could be enough to prevent the deepest layers from freezing solid. If this theory proves correct, Pluto would join a growing family of ocean worlds within our solar system. Moons like Europa and Enceladus already show strong evidence for underground oceans. Now Pluto may belong on that remarkable list as well. The possibility raises an exciting question. Where liquid water exists, could life also survive? Scientists are careful not to make extraordinary claims without evidence. No one has discovered life on Pluto. But Earth's own history teaches us that life can flourish in places once considered impossible. Microorganisms survive beneath Antarctic ice sheets. Others live deep below Earth's surface without sunlight. Some even thrive near hydrothermal vents where crushing pressure and extreme temperatures would kill most known organisms. These discoveries force scientists to rethink where life could exist beyond Earth. Perhaps sunlight is not always necessary. Perhaps hidden oceans beneath thick layers of ice can provide stable environments for biology over billions of years. The mystery grows even deeper when scientists study Pluto's atmosphere. Although incredibly thin, it behaves in surprising ways. Nitrogen, methane, and carbon monoxide slowly freeze onto the surface before evaporating back into the atmosphere as Pluto travels around the Sun. This constant cycle creates changing layers of atmospheric haze. Modern infrared observations allow researchers to examine these changes with remarkable precision, revealing details impossible to detect just a few years ago. Every new observation paints Pluto as an active world rather than a frozen fossil. And yet, we have only begun to understand what lies beneath its icy crust. If Pluto truly hides a liquid ocean beneath its frozen shell, then one of the biggest questions in planetary science suddenly becomes impossible to ignore. Could that hidden ocean support life? Scientists are careful when discussing this possibility. There is currently no evidence that living organisms exist on Pluto. But history has shown that nature often surprises us. For many years, researchers believed life required sunlight, warm temperatures, and Earth-like conditions. Then they discovered entire ecosystems thriving around deep-sea hydrothermal vents, buried beneath kilometers of ocean where sunlight has never reached. Microbes have also been found inside Antarctic ice, deep underground in solid rock, and in some of the harshest environments on our planet. These discoveries have completely changed the way scientists search for life beyond Earth. Instead of asking only whether a planet is warm enough, researchers now ask a different question. Is there liquid water? Is there a long-term source of energy? And does the environment remain stable for millions, or even billions, of years? Pluto may satisfy more of these conditions than anyone once imagined. Another mystery involves Pluto's relationship with its largest moon, Charon. Unlike most planet-moon systems, Pluto and Charon orbit a shared center of gravity located between them. Their gravitational interaction constantly pulls on Pluto's interior, creating stress beneath the icy crust. Some planetary scientists believe these tidal forces generate additional heat, slowing the freezing of any underground ocean. If true, Pluto may still be changing from the inside out. Its surface certainly hints at an active past. Towering mountains made of water ice rise several kilometers into the sky. Wide valleys cut across frozen plains. Immense fractures stretch for hundreds of kilometers, suggesting the crust has expanded and shifted over time. These are not the features expected on a completely dead world. They tell the story of a planet that may still be evolving. Even Pluto's thin atmosphere refuses to remain constant. As the dwarf planet follows its long 248-year journey around the Sun, frozen gases slowly evaporate from the surface before freezing again as temperatures fall. This continuous cycle reshapes the atmosphere and creates delicate layers of bluish haze extending high above the surface. Modern infrared observations are helping scientists monitor these seasonal changes in greater detail than ever before. Perhaps even more fascinating is Pluto's unusual chemistry. Frozen methane exposed to ultraviolet radiation gradually transforms into complex organic compounds known as tholins. These molecules give Pluto many of its reddish colors and represent some of the chemical ingredients that may contribute to the formation of more complex carbon-based materials. Although they are not proof of life, they demonstrate that surprisingly rich chemistry is taking place on one of the coldest worlds in our solar system. Pluto also raises an even bigger question. If such a small and distant object can remain active for billions of years, how many other icy worlds are hiding similar secrets? Beyond Neptune lies the Kuiper Belt, a vast region containing thousands of frozen bodies left over from the formation of the solar system. Many of them remain almost completely unexplored. Some could possess underground oceans. Others may contain unexpected geological activity. A few might surprise us in ways we cannot yet imagine. Every discovery made about Pluto encourages scientists to look more closely at these distant worlds. Future missions may eventually orbit Pluto for years instead of simply flying past it. Advanced radar systems could search beneath the ice. Powerful instruments could study its atmosphere in unprecedented detail. One day, robotic explorers may even drill through the frozen crust to investigate what lies below. Such a mission would answer questions that have remained hidden since the birth of the solar system. Pluto's greatest lesson may not be about one distant dwarf planet. It is about how easily assumptions can be overturned. A world once dismissed as cold, inactive, and scientifically unimportant has become one of the most intriguing destinations in planetary science. Every new observation reminds us that the solar system is still filled with mysteries waiting to be uncovered. Perhaps Pluto's hidden ocean exists. Perhaps it does not. Perhaps future missions will discover entirely new processes that nobody has yet imagined. Whatever the outcome, Pluto has already changed the way we think about icy worlds, planetary evolution, and the search for life beyond Earth. Sometimes the greatest discoveries are not found on the largest planets. Sometimes they are waiting quietly at the very edge of the solar system, where a small frozen world continues to challenge everything we thought we knew. And perhaps Pluto's greatest secret is still waiting beneath its silent ocean of ice.